So if you could put this heading down, comparing fractions and operations with fractions. Okay, this is revision. You guys, so this one moving quite quickly. You need a hand with this. Make sure that you check with me what you need to know or what you need to do. So please make sure that you are familiar with how to do all these things. Okay, operations with fractions, comparing fractions with scale. That was a test. Yes, this is going to be uploaded and I'm going to have access to it. So you'll have access to it. Yeah, this is a much simpler system. Yes? Yes. It is recording right now. Guys, please, if you do that, it can be a bit hard to pick me up at times, so please just make sure that this is for people who are away, and if you're away, you can easily catch up. There's no problem with me having to do anything with you. You get the full lesson, you get the full notes, so it's very sort of handy way of... Okay, yes, Sean? I'll show you how to look at these things. Yes? No, it records what I'm doing on the screen. Yeah, it records our voices, records my voice, and records everything I do on the screen. Does this make sense? Does everyone understand now? Screen capture. It's called screen capture. It does everything that I'm saying right now, and it's really recorded in detail, so you can go back over this conversation many times in a circular way. Good. Now, we talked about this. Listen carefully. When comparing fractions, if you want to compare them to see which is greater or lesser, we need to have the same denominator. Okay, there's no point comparing fractions if the denominator is different. It's very difficult to see which is greater than which. Okay, it's actually not possible exactly to see. So, hang on a second, Sean. The easiest way to make the denominator the same is to multiply the denominators together to find a common denominator. Okay? Yes, Sean. Alright, so if you have two fractions, the way that you find the common denominator, and you change both, is to multiply them together. So just watch what I do, and again, I've seen this before, Alexis, and Shamian. So the common denominator, for those not familiar, I might just write denom, or denominator, so just abbreviate, okay? You've got 5, you've got 9. So the easiest way to do it is just 5 times 9 equals 45. So that's our common denominator, which is 45. Now, then I have to change both of these into fractions with a denominator of 45. Okay, so you can think of it like this. Well, 4 over 5 equals something over 45. Alright? Now the question is, what goes in this numerator on the right-hand side? This comes back to equivalent fractions, how we think about that. So, Brock, what do you think goes in the top? 36. How did you get 36?
5 times 9.
Good, excellent. So if you multiply the bottom by 9, you have to multiply the top. So we multiply it by 9, and so we get 36. So 4/5 is 36 over 45. Alright? We do the same for 6 over 9. 6 over 9 equals what over 45? Show me. So how did you get from 9 to 45? 9 to 45. How do you get from 9 to 45? Good. Times it by 5. You times the bottom by 5. What do we have to do? Everyone stand up and read this line, please.
Good morning, Mr. Warren.
Alright, so Charmaine, you're saying, how do you get from 9 to 45? 5. So then what would we have to do with the numerator? Times it by 5. So again, we times the 6 by 5, and so we get 30 over 45. So which is greater? Which is greater? 4/5 or 6 over 9? 4/5. Why is that? Good. Exactly. Okay? So 36 over 45 is obviously greater than 30 over 45. Therefore, we can say that 4/5 is greater than 6 over 9. All right? Any questions? Yes, ma'am. Yeah, because if we times the bottom by 9, then we also have to times the top by 9. We're making it quicker. Changing it, yeah. We're not changing the value, we're just changing the way it's written. Alright, make sense? Good. Moving on. Oh, don't move on, yeah. Just go do that. Yeah. Yeah, that's the easy. Sometimes we can get it lower, but not as high as it was. But in this case, the easiest way also. Okay? Good. Now, if there are, in English, if there are more than two fractions to compare, then you multiply all the denominators together to find the common denominator. Okay? If you have 3, like in this example, we have 3 over 5, 4 over 7, and 5 over 9. Arrange them in ascending order, we find a common denominator, which is 5 times 7 times 9. Now, there probably is a multiple which is lower, but the easiest way is just to do that. So I'm going to just put some space in here. I'm going to, oops. I'm going to do this one here. Okay. So if you have a look here, so the common denominator equals, so the denominators are 5, 7, and 9. So the way that I would approach this question, instead of wasting time finding or wonder what the common denominator could be, I'm just going to say, let's just make it 5 times 7 times 9. Find this out for me, please, Sean. Do 5 times 7 times 9. 35 times 9, which is 315. Okay, so 315. So let's have a look. 3 over 5 equals what over 315? What do we have to multiply 3 by here? Oh. No, well, how do you get from 5 to 315? Yeah, but we've already got the 5 here. So we need, what's left? 7 and 9. So we have to do times 7 times 9. So what's 3 times 7 times 9?
189.
189, thank you. Okay, and then we got the 4 over 7 equals something over 315. Now it's important that you take note. To get from 7, we have to multiply it by times 5 and times 9. So what do we have to do with the 4? Yeah, that's right. We have to multiply the 5 by that. Oh, sorry, we have to multiply this numerator, which is 4, by 5 and by 9. So we do times 5 times 9, which is 180. And then the last one, 5 over 9 equals something over 315. Well, again, you have to multiply it by 5 and 7. So what do we have to multiply this by? Whatever's left. 5 and 7. So what's 5 times 35? 175. Okay? So which of these three is the smallest? Yeah, 5 over 9. This is the smallest. This one's the second. And this one's the third. So in ascending order, we write it as 5 9ths is the smallest, 4 7ths is the next biggest, and 3 5ths is the biggest. That's one way. What's the easiest way to answer a question like this? Use your calculator. 3 divided by 5, 0.6. 4 divided by 7 is something a bit less. 5 divided by 9 is something a bit less. Okay, but it's good to know the sort of understanding of what's happening in this. What you're actually doing by changing denominators and comparing. Okay? So write this example down. You can always check it with your calculators. Yes. Why is it 310? Oh, that's what it is. That's what 310 is. 5 times 7 times 9 is 310. Yeah, you see how it's done. Yeah. Okay? Yes, Charlie.
If you would be like this is going to work, but if you would just sit for your part, you get this after your why.
While I'm doing it.
Yeah.
No, that's not set up. Sorry, not live casting. Like a concert or something. Listen live on YouTube to the McIntyre channel. Can you feel the beat? That's right. Okay, just relax. Okay, now write the next heading, operations with fractions. Now, operation with fractions, again, this is something that you know, but we're just going to go over it. Yes, Kayla? Yes. Now, the reason that we take the trouble of comparing fractions is that you have to do the same thing when you're adding and subtracting. Right? So, and especially this, obviously when it's just numbers, you've got to use your calculator to do it. But later when we get into the algebraic fraction, you can't put it into your calculator. So you have to understand what you're doing when it comes to common denominators, multiplying top and bottom, equivalent fractions. All these things are very important because it's not just about getting numbers right, it's actually about understanding what's happening when you get into symbolic and sort of abstract things when we talk about algebra. So when adding and subtracting fractions, the denominators must be the same. You know that. Okay? The denominators must be the same when you're adding and subtracting. This applies more to algebra stuff. Change the denominators to a common denominator by multiplying by the appropriate quantity. Okay, I haven't put a definite thing, it depends on the case. But you need to multiply one or both to change the denominator. That's the way that we go about it. And always remember, as much as possible, you need to simplify fractions. When you're done with the answer, simplify by dividing the numerator and the denominator by common factors. Alright, so just a common factor of 2, let's divide top and bottom by 2. 5, whatever it is, always write fractions in its simplest form. You don't want to be writing it in 18 over 20 when you divide it as 9 over 10. It's much better and easier to handle in its simplest form. So always write it in the simplest form for a fraction. Okay? So finish this part. So today is a little bit more writing than usual. Let's just sort of go through these things. Okay. Tomorrow we don't have a lesson either, so I want to cover a bit extra, so over the next couple of days. Yes? You did that. What do we do? I will show you after. This will also be available in numerous forms. Yes? It's all available online. Okay, Now, looking here, let's just do this example here. So quarter plus 2/5. What's the common denominator? There's certain ones you just need to learn and know what the common denominator is. Good one. 20, yeah? So 20, so what 1 over 4 is 1 over 20. 5 over 20, okay? 5 over 20 plus 2 over 5 is 1 over 20. 8 over 20, good. So what is our answer here, Lyndon?
13.
Good. It's 13 over 20. Can that be simplified at all? Any common factors?
No.
No. Yeah, because 13 is a what number? Prime number. Good. So 13 over 20. I've found what the common denominator is, multiplied them, I've found it, I've changed them, and now I have my solution. And I can't simplify it, so I leave it as 13 over 20. Let's have a look at the next one. 7 over 8 minus 5/6. What is the common denominator of 8 and 6? What's the lowest common denominator? Right. That's the lowest common. What's the thing that they both go into? What's the lowest?
What do you think? 6 and 8.
Yeah, 6 and 8. It's actually 24. 24. Okay? So 6 goes into 24, 8 goes into 24. There's no other number, there's no lower number which both 6 and 8 are a factor. So they're both factors of 24. That's the idea of the lowest common multiple. As in what multiple of both these numbers, which is the lowest. How do I get from 8 to 24? Times by 3. Good. So we have to do something over 24. That's 21 over 24. Minus, how do I get from 6 to 24? Adam? Good. So it's going to be 20 over 24. So 7 over 8 and 5/6 are actually very close. All right, we've got 21, so that's going to be what? Yeah, 1. And obviously you can't simplify that at all. Okay? Any questions? Makes sense? Familiar? Big? Just the maybe?
Yes.
Sounding very familiar.
Yeah.
Excellent. Good. All right, I'm just going to do one last one of this one. So, there's 2 methods you can do for this one. I'll do one method here. Method 1. When it's a mixed numeral like this, you can take the numerals out, add them together, and just leave them to one side, and deal with the fractions. Alright, so what we can do is say, well, this is 2 plus 4 plus 3/4 plus 6 over 10. I can come back to it. Take note. I just wanted to make sure people see this. All right. So you're adding the 2 and the 4. Then you're adding the 3/4 and the 6 over 10. So 2 plus 4 is 6. What's the lowest common multiple of 4 and 10? It's 20. 20. So 4 goes into 20 and 10 goes into 20. So we have to change this. How many times does 4 go into 20? 5 times. So this is going to be 15 over 20. Now, these sort of things, converting fractions, you just have to now be able to, equivalent fractions and stuff, you have to start getting much more fluent at. These are the sort of things, techniques that you just need to be moving a bit quicker over. You need to practice them, you need to do that. But just knowing that, okay, 3 over 4 is 15 over 20. You can just convert that very quickly. Okay? And then 6 over 10 is 12 over 20. And so what we end up with is 6 and 27 over 20. What's wrong with this? It's a mixed numeral with an improper fraction. We cannot have this. What do we need to do, Daniel? Good. How do we do that? What is, someone said it? 7 and 7/20. Good. So it's 6 plus 1 and 7/20, which equals 7 and 7/20. Alright? I'm not going to do the second method because I want to keep it. And the second method is longer. Yes?
So everything in university will be on that unit line figure?
Yes. Yes. Yep. Sorry? Yes. There'll be a PDF file that I'll put in the folder for this class. I'll put the PDFs for all the lessons. Okay? So you have the notes and you'll have the lesson with the video. So you can, wherever away, you can have the notes and while you're looking at the notes, listen to the lesson if you're so designed. Yeah? Look at that. Okay? Not weird. Not strange. It's in my computer. All right, moving on. Over the pages today. Multiplying fractions. Multiplying fractions is even more straightforward than adding or subtracting. All you do is multiply the numerator and multiply the denominator. Right, that's all you do. Multiply the numerators together, multiply the denominators. Okay, Matt, you always simplify. Alright? That's right. That's right. Good. So remember that. Just simplify if possible. If it's not possible, you can't. Now, one thing you need to remember, and this is a note really, that an integer, because often people get confused. When you have just a number, or just a numeral like an integer, multiplied with a fraction, often people will multiply the denominator and the numerator with that number. Okay, but that's not what we're doing. An integer is a fraction with the denominator 1. Okay, so when you multiply an integer with a fraction, the denominator is just 1 that you multiply with the other denominator. So we'll have a look at an example. So 2 is just 2 over 1. 5 is just 5 over 1. Minus 6 is just minus 6 over 1. It's just, you don't need to write the denominator of 1 because anything divided by 1 is just the same. So this is the important thing to remember. When you're multiplying an integer with a fraction, you multiply just the numerator. Right, we'll have a look at the example. And if there are mixed numerals to multiply, you have to change them into improper fractions first. And this is why I say more and more you'll stop using improper mixed numerals, and move towards improper fractions, because that's much more easy to handle. There's all sorts of operations later on with algebra and all sorts of things. Much easier to handle improper fractions than mixed numerals. So start just using improper fractions. Okay? Because when you multiply them, you have to change it to improper fractions. So are there any questions before I do it? Okay, so moving on. Right, so let's just have a look at these examples. These examples, if it's obvious to you, you don't have to write it down, just listen. 3 over 5 times 4 over 7. All we're doing is multiplying the top. So 3 times 4 is 12, 5 times 7 is 35. Can we simplify this? No common factors. Okay, that's just the way it is. Now this one is what I was talking about earlier. An integer is just a number, a fraction with denominator 1. Is that right, Andy? So what would 9 be as a fraction? Yeah. So that equals just 9 over 1 times 3 over 5. So 9 times 3 is 27 over 5. Just leave it as improper, that's fine. Unless it asks you to write it as a mixed numeral, you can leave it. Is this 27 and 5 any common factors? No. 6 and 4/5 times 3 and 2/3. What do you have to do first in these, Emma? These are what? What are these things called? Yeah, good. Let's do that. So what's 6 and 4/5 as an improper fraction? Good. 34 over 5 times, what's 3 and 2/3 then as an improper fraction? Good. 11 over 3. What's 34 times 11? Josh. 374. You know what? Oh, that thing. Okay, hang on a second. So we got 374 over, what's 3 times 5? Good, thank you, Matt. Okay, 15. Any common factors? No, I don't think so. If you type it in your calculator, it simplifies it for you, but I don't. Okay, so then that's what you'd leave it as. Okay? Sorry, Josh, what do you want me to move it down? Okay, any questions? Does that make sense? Changing improper fractions to, changing mixed numerals to improper fractions. Multiply numerator with numerator, denominator with denominator, and simplify again. Okay. Final thing for the day. Final thing. Reciprocals and dividing fractions. Reciprocals and dividing fractions. The definition of a reciprocal is that when you multiply a number with its reciprocal, what do they multiply? What's the product of a number and its reciprocal? Always. 1. A reciprocal and it's a number and its reciprocal multiplied together is always 1. The product is always 1. So, the reciprocal of 2 is a half, 1 over 2. Reciprocal of 3/4, 3 over 4 is 4 over 3. What you're doing, you're just flipping. You're just flipping the numerator. Okay, thanks. So that links in with, when you're dividing fractions, Shami, what do you do when you divide fractions? Multiply and divide. Okay, let's just listen. Make the second one, find the reciprocal of the second fraction, you change the division to a multiplication. Okay? Find the reciprocal of the second fraction, and then you multiply instead of divide. So you're just flipping the second one over and changing it to multiplication. So the final thing I just want to do is two examples. So 6 over 9 divided by 8 over 3. 6 over 9. You find the reciprocal of 8 over 3, which is 3 over 8. And then you multiply it. So 6 times 3 is 18. 9 times 8 is 72. Is a common factor? What's the common factor? Yes, 9. Yeah. It's good. So it's actually no, it's 18. Oh, that's right. It's 2 over 9, 2 over 8. Sorry, equals 1/4. That's 1/4. This one you have a mixed numeral, so we have to change it into an improper fraction. So the first step is, well, that's going to be 14 over 3 divided by 5 over 6 equals 14 over 3 times the reciprocal, which is 6 over 5. So that equals 84 over 15. And we can simplify that, which is 28 over 5. Alright? So those are the operations. How we multiply, how we divide, how we add and subtract, how we compare fractions, the reciprocal of a fraction, right, all these things. So these are the exercises, 1.03, and the questions are up here. So we'll just write them out on the board. So 1.03.